Welcome back to 30 Days of Physics with Miss B, and we're moving right along into gas laws. Kinetic theory of matter. The particles of matter are in constant motion of vibration, translation, or rotation. The kinetic energy they possess is responsible for their temperature or hotness. There is space between particles. Forces pull them together when they are near to each other, and so the particles have potential energy. When a substance is heated, the heat energy supplied could result in an increase in the kinetic energy of the particles of the substance, and hence in its thermal energy, causing the temperature to rise. When a substance is heated so that it changes state, the heat energy supplied results in an increase in the spacing of the particles and hence an increase in their potential energy, allowing them to break bonds with their neighbors and to expand against any surrounding pressure. The gas laws are relationships between different variables used to describe gases. The four variables include pressure, temperature, volume, and amount. Here's your introduction to 5 gas laws. We have Boyles Law, Charles's Law, Gay-Lussac's Law, Avogadros Law, and the Combined Gas Law. What is Boyles Law? Well, Boyles Law investigates how a gas behaves when pressure and volume are altered while done at a constant temperature. His law states that pressure is inversely proportional to its volume for a fixed mass of gas at constant temperature. Mathematically expressed, P1 V1 is equal to P2 V2. In other words, when the pressure of a gas increases, its volume decreases at constant temperature. Here's a graphical representation of Boyles' law. What is Charles's law? Well, Charles's law investigates how a gas behaves when volume and temperature are varied while done at a constant pressure. Boyle's law states that volume is directly proportional to its absolute temperature for a fixed mass of gas at constant pressure. Mathematically expressed, V1 over T1 is equal to V2 over T2. In other words, increasing the temperature of a gas increases its volume at constant pressure. Here's a graphical representation of Charles's law. What is Gay-Lussac's law? Gay-Lussac's law investigates how a gas behaves when pressure and temperature are varied while done at a constant volume. It is sometimes referred to as the pressure law. Gay-Lussac's law states that pressure is directly proportional to its absolute temperature for a fixed mass of gas at constant volume. Mathematically expressed, P1 over T1 is equal to P2 over T2. In other words, increasing the temperature of a gas increases its pressure at constant volume. Here's Gay-Lussac's law graphically represented. What is Avogadros Law? Avogadros Law investigates the relationship of the molecules of a gas with its volume at the same temperature and pressure. Avogadros Law states that equal volumes of all gases at the same temperature and pressure have the same number of molecules. Mathematically expressed, N1 over V1 is equal to N2 over V2. Avogadro noticed that increasing the quantity of a gas increases its volume, and that the same amount of moles of any gas occupies the same amount of space. Here's a graphical representation of Avogadro's law. Combining Boyles, Charles, and Gay-Lussac's laws, we get P1 V1 over T1 equals to P2 V2 over T2. This law is applied to ideal gases. However, there is no such thing as an ideal gas since intermolecular forces exist between them. But These forces are ignored since gases almost behave ideal at standard temperatures and pressures. Any equation involving the variable temperature should be in units of kelvins. The Kelvin scale is also known as the thermodynamic temperature scale or absolute temperature scale. Different types of units may be used for pressure, volume, and moles as long as they mirror both sides of the equation. For example, different units for pressure include atmospheres, millimeters of mercury, torr, etc., while different units for volume include cubic millimeters and cubic centimeters, etc., and millimoles for moles. Let's try a question. A ball contains 50 cubic centimeters of air at 15 degrees Celsius and a pressure of 1 atmosphere. Find the pressure when the air is compressed to 10 cubic centimeters and its temperature rises to 30 degrees Celsius. Pause the video to try the question. First, list all variables. V1 is equal to 50 cubic centimeters. T1, when you convert 15 degrees Celsius to kelvins, you get 288 kelvins, and the P1 is equal to 1 atmosphere. V2 is equal to 10 cubic centimeters. T2 is equal to 303 kelvins once 30 degrees Celsius is converted, and we are looking for P2. Next up, we transpose for P2 using the equation P1 V1 divided by T1 equal to P2 V2 divided by T2, and then we get P2 is equal to P1 V1 T2 over T1 V2. Finally, we substitute all of the variables for the values mentioned in the question, and we get P2 to be equal to 5.2 atmospheres. Alright guys, I'd like to thank you for watching this 15th session of 30 Days of Physics with Miss B. See you for day 16. Bye!